The schedule is such that this talk ends after Q&A. You got 10 minutes to get to any other talk. So please don't leave during the QA session. It's rather rude. Thank you. So this morning's first session is Moshe Zadka, a core Python developer since 1999, and a Twisted developer since 2000. Please give him a hand.
Hi, everyone. So my name is Moshe Zadka. I'm going to talk to you about automating AWS. So before we start, just one note. We will not have a mic to answer questions. If you have questions, there's a URL. If you are not good at remembering long strings of letters, I tweeted that URL. It's pinned to the top of my tweet. If you Google my name, you'll find my Twitter. So basically, just if in the middle of the talk, you can put questions whenever you want, or in the Q&A session, and I will choose the questions that I think are most relevant when it's time for Q&A. So why should you even automate your AWS setup? You want to make sure that it's reproducible. And sometimes even more important, some functionality is actually not available through the UI. So basically, my recommendation is to treat the UI as read-only. Look that what you've seen is correct. If it's not correct, obviously fix it. But do not make any actions through the UI because they are not reproducible. A large part of setting up correct AWS is to set up all the accounts correctly. I'll give a spoiler for where I'm going to go, and then we'll kind of reach there step by step. So we're going to talk about having a billing-only account and how to set up that you can have no root access to all the other accounts, which will probably be something along the line of production, build, staging, demo, dev, and so on. So root account is the same as the AWS account you created. So if you log in with an email and a password, that is your root account. And it is very similar to a root on Linux. It has all the abilities to do anything. There is no way to limit it. An IAM account belongs to an AWS account. So in your AWS account, you will have IAM accounts. Nobody remembers what IAM stands for. Definitely not me. Something like account management. But there are IAM accounts. They belong to the AWS account, so they're local to every AWS account. And it has a security policy. You can limit what it can do and what it can't do. You can set a password for an IAM account. That is optional. It does not have to have a password. If you do set a password, which means now people can log in as that IAM account, you probably want to set a two-factor authentication. There are a handful of options for what kind of two-factor authentications are possible. You want to use one of them because that account probably has some control over some critical part of your infrastructure, and you do not want that control to be in the hands of someone who is not friendly to you. And those accounts are meant for human users, meaning your colleagues or your friends or whatever, they want to log in and look at the console. Again, ideally, only use that for read-only access. An API key is also something you can attach to an IAM user. Again, it is optional. Humans usually do not need API keys. But if you do have an API key, you can have up to 2. So any number from 0 to 2 API keys is possible. And these are meant for robot users, right? And you should have them for whatever robot actions you want to create. And since you're going to automate, you're probably going to have a few robot accounts for doing various things. Now, after you have your users and you have them properly credentialed, you can start applying policies to them. So as I said, root can do anything. There is really no way to apply a policy to root. That is fine because you should never log in as root. Admin policy is almost anything. I don't remember what it limits. I think actually nowadays it limits literally nothing. It's one of the default policies in AWS. So if you want to have a user who is as powerful as root, you can just give them admin policy. There is no reason forever to log in as root, unless you somehow lost a credential and you need to recover it or something very critical like that. The policies are extremely customizable. It's hard to show extreme customizability on a slide. So what I have a slide is a little bit customizability. In this case, I want an account that can do almost anything, but I want to disable any IAM because I don't want them to be able to create other users, so they can't try to log in as other users, in which case I would kind of lose the ability to track them. This is a very, very simple policies. Most policies are way, way longer, but they would not fit on a slide. You want to use a feature of AWS called Consolidated Billing. I realize this is a move of engineers. I'm also an engineer, and I'm talking about the billing feature, but this is one of the best features that AWS has. So you can create a master account, and then you can create sub-accounts from that master accounts that will actually control resources. If you read blogs about these things, as of like, yeah, I think it changed reasonably recently. I haven't kind of kept up, but I think early 2017 or mid 2016, it kind of made it a lot easier. You can actually have just a master account and sub-accounts. It used to have that you created the account separately and then used all kind of complicated workflow to connect them. This slide used to have that workflow. It does not, because you should not do that. You should do the right thing. But if you already have AWS accounts, be aware you're not lost. You can actually still connect them with a complicated workflow and have a consolidated billing for everything. When you get the bill, it is easy to separate out. You get one bill, but it separates what account caused what charges to be made. So how do you achieve corporate awesomeness? You give only admin and finance people access to the master account. There is no reason for you as engineers to ever access a master account. It really should be used only for billing purposes. They should be able to pay it out. They should be able to check the bills, do whatever it is finance people do with bills, which presumably is very important, but I have no idea what it is, and leave you alone to deal with the engineering stuff. On the other hand, the admin finance people should probably not be controlling any cloud resources. EC2 instances, volumes, and things. We will talk about this later. So the master account, the bill for the master account itself should be 0. When you actually have the separate out, if it is not 0, you should probably figure out why it's not. You want a separate production account for using facing, ideally limit how many people have access to that account. You probably want a staging account for your various staging environments. You want a dedicated build test account, because build and test is a production system, right? If you cannot build, you cannot fix bugs. It is a production system. You want to be able to limit access to that. On the other hand, it should not be the same account as production, because if for nothing else, you want to make sure that you know what you're paying for, right? At some point, someone who's actually footing the bill for your wonderful resources will ask you, what are we paying for? You want to make sure that you can tell, this is how much we are paying for building and for testing. Yes, I realize that we're paying a lot for testing, but this stops us from having bugs. And this is how much we're paying for production. This is per user. This is how we separate out this cost. This stuff is really important. It's nice that it's easy to kind of show the people who are in charge of the money. And you want a separate account for what you might call pets, meaning certain instances that people use for their own purposes. They have a special attachment to them, like, for example, a dev machine, or my weird staging environment that is supposed to reproduce weird bugs, and I build it exactly the way I know it, and I'm not really sure how to ever build it again. You know, ideally not, but people do need these things sometimes for ad hoc reproductions. You want a separate account for the pets. So now that you have all these accounts, you want to apply the correct policies. The prod, stage, and build, which is also a sort of prod, you want to make sure that all the resources are automated. They're tagged with a reason which ideally should make sense to a business person. Like, what product is this building for? Is this the app? Is this the partner-facing stuff? What is this doing? Why am I paying for it, basically? The pets should be tagged with a specific dev name. By definition, a pet belongs to a person, right? Who that person is should be on that resource, and you should garbage collect by default, because people are really, really bad at forgetting to clean up their M2 instances extra large, which are costing like around like $5,000 a month, and it's really, really hard to explain why you're wasting $5,000 a month. So you want the garbage collection by default, and you want to have some policy to avoid garbage collection that is understandable. For example, tag with when you want me to garbage collect and explain a reason. So now that you've set up everything, you're going to want to automate, right? Finally, what this talk is about. So you want to use Boto 3. That's a Python 3 SDK that is by Amazon, and it's pretty well maintained. You want to connect that to the accounts. As I said, you want to have dedicated bot accounts. You tag them with an IAM policy. And now you finally get to generate an API key so you can do some stuff. You need admin permission, or specific admin permissions. You can apply just the right IAM permissions, but usually you just give admin permissions to generate the API key. Saving the API key is hard. I have literally zero advice for that, because that probably depends on how you anyway do sort of dev setup. There's various ways. There's ways to avoid needing the API key in the beginning, or you want to use a secret management system like Kiwis or Vault or Docker Swarm secrets. So like all these things, they're all really hard to use, and I do not have good advice, except you will suffer. Keys do have a publicly shareable part. This is a great feature because you can log that, and that publicly shareable part is something you can look at the console. This is very useful because you can tell if the robot is not managing to log in because they're using an out-of-date key. So now that you log the keys, you're ready to kind of actually automate these things. But first, you want to make sure that you have a good key rotation policy. So I said you can have up to 2 API keys per user. This is very, very useful because that means you can generate a second key, you can deploy it to whatever secret management scheme you're using, and you can invalidate the old key. Invalidation is a very important operation because it is reversible, unlike deletion. So after you invalidate, you can wait as long as you want to make sure that that deployment of the secret took hold. Because the first time you will do it, you will somehow forget to deploy the secret to the other system that is failed over only once a day. So you can wait a day or a week, whatever time you feel like you need to make sure that we are not using the old key anymore, and only then delete it. If you see that you are using the old key anymore, you will get an error, but that error is easy to fix. You just revalidate the old key. Now everything is working, no more production problem, and you can, again, redeploy the second key appropriately. After the invalidation has been shown to be safe, then you can delete. So you have your keys, you have your rotation policy, you're ready to actually start up a machine. Where? Oh, wait. Now we need to understand how regions and availability zones work, and there are some subtleties here. So regions are geographical areas. For example, we are here, the closest data center to us that Amazon has is Oregon, or as it is called in the API, US West 2. Availability zones are composed of data centers that are somewhat remote from each other, so they are kind of redundant. A disaster on one should ideally not harm the other one. They have several data centers in Oregon, and your account will have access to one of them as US West 2A. Now, here's a subtle thing. That depends on the account. If you have a production account and a staging account, the data center that your production account calls US West 2A is not necessarily the data center that your staging account calls US West 2A. They'll still be in the US West 2 regions, but they might be different data centers. You should not assume that they have any higher connectivity than, say, A and B. Okay, now we finally get to actually start instances. Instances are just virtual machines. You probably occasionally run virtual machines on your laptop. These are really no different, running on a slightly different virtualization system. And there's the basic compute unit. Probably most of what people buy from Amazon is EC2 instances. There are a lot of sizes and a lot of costs, and it depends on a lot of parameters. And this talk is already way, way too long before I get to show you any Python code, so I will not delve into that, except to say there's like a whole list of prices, and you can check what you get for what you pay. So when you start up your EC2 instance, it uses a Python package called Cloud Init. This is pretty awesome because Cloud Init is super highly configurable. So it basically will grab the instance metadata, which is composed with metadata you attached via the API and some metadata that Amazon automatically attached, and it can do all kinds of fancy stuff. The typical least fancy thing you can do is, for example, if you set a metadata key called SSH authorized key, that will set the SSH authorized key for root, and you can access root on the box. Which brings us to, in general, how to SSH into EC2 machines. Ideally, again, you won't do it on a day-to-day basis unless you need to use it for the automation part of your stuff. But you will probably do that occasionally. So you can generate a key pair on AWS. They keep the public key, they give you the private key, and they forget the private key. If you do not trust them to properly forget the private key, you can make your own public private pair and upload only the public part. Notice that the name of that is region-specific. It is not zone-specific, but it is region-specific. So you can have a key called, say, Moshe in US West, thank you, US West 2 and US West 1, and they can be different keys. That will probably confuse you to no end. So you probably want to either name them based on the region or generate one private public pair and upload the same public key to everywhere. So you have your key, and finally we get to actually SSH. No, you do not get to SSH. If you SSH now, then you will get the little seemingly harmless prompt saying, I don't know that host. Are you sure that that blob is safe? And you will say why. And at that point, you have been man in the middle, potentially, because you have no idea whether that blob is true. And now we have just authorized someone to access your system, and now you have taken over all your private data, and that is very sad. So you should not do that. Instead, what you should do is you should grab the console output from the EC2 box using Boto3, and you should check what it thinks its SSH RSA identifier is. You grab that line. Unfortunately, that is basically supposed to be human readable, and you want to automate, of course. So you need this weird ad hoc parser that will just slog through the lines. Luckily, Python is pretty good at that stuff. And basically add it to the .sh known host file. Of course, you can customize which file SSH looks at, but presumably, if you need the default, that is where the file is. Wow, that was a lot of talking, so it went to sleep, of course. Okay. So you managed to append to known host, and now, finally, it is safe to SSH. You probably want to, the first time you do it, make sure you did it correctly. That is how the last line should look at. For readability, it is broken into multiple lines. It will not be broken into multiple lines for readability in your SSH known hosts. You've set your EC2 machine, and now you probably want to build a lot of EC2 machines. And there's various things you can do. You need to start from what they call AMI, which is an Amazon machine image. So you have a bunch of ready-made ones. There's Amazon Linux, which is basically a CentOS derived. There's CentOS, there's Ubuntu, there's pretty much any Linux distribution you can think of. Or you can roll your own. You can share AMIs across accounts. This is actually very useful because you can create the AMIs from your build account, which is properly protected, and then share them to, say, both your pets account and to your production account. You never want to put secrets in the AMIs, partially because they can be shared across accounts, and so they cannot be properly encrypted, partially because it's very hard to control who actually boots from your AMI, so any secret can be basically distributed randomly. Why would you ever want to build your own AMIs if you have all these wonderful AMIs pre-built? You probably want to make sure that you know exactly which security updates you've gotten. You probably need some software that is specific to your use case. And you might have some configuration that you like that other people would not like. You can use just SSH to build AMIs. You'll notice that there is no prompt here for the SSH because we have already set known hosts correctly. And then you use the Boto3 API to do create the image. If you have something more complicated than YAM update, then probably it gets very annoying to start automating that with SSH. You can automate it the same way you automate any other configuration system, right? So, for example, you can use Salt. In this case, we use PEX to build a Salt PEX, so it will be easier to install PEX on the remote host. So we can put PEX on it, we can put the Salt configuration, and we can set Salt to a local file root, and then we have exactly the configuration we need. This is actually very useful if, say, you use Salt for post-boot configuration, because you can move things back and forth as is appropriate. So you want to use the same configuration management to build your image as what you're going to use to actually manage your image post-build. Now you have the AMIs, and you're all ready to go. And you probably need more than one machine, because you're doing a 3-tier or something like that. And of course, you could just boot them up in sequence and figure out which one belongs to which one, but that's very annoying. So use something called CloudFormation, which basically gives you a way to build a self-contained environment. So CloudFormation templates are just JSON file, plain old JSON. They can be parameterized. For example, the most popular parameter is probably the key name because you want different developers to use their own keys when they try out the CloudFormation template. They can be self-referential, so you can define something and then refer to it in itself. So you can make a volume and say that volume should be attached to that EC2 instance. This is literally the smallest CloudFormation template I could find that would actually do something useful. So I'm sorry for that density and how I formatted to fit the slide. But I want to point out several interesting features. So you prioritize on the key name, you build some resources, and you'll notice that, for example, when I ask for the security groups, I say, give me the security group that I have asked for, that I have created here, so I know that I can SSH into that machine. This is very important. The default security group would not allow you to SSH into the machine, which is sometimes useful. So how do you create this JSON? Well, you can just use JSON dumps, create a bunch of lists, dictionaries. That works surprisingly well for quite a bit. But at some point, you might run into problems like you misspell the name, and then you only realize it halfway through your CloudFormation. That is never fun for anyone. Troposphere is a great library to make sure that the names you have are checked at the Python level. You see that I have ref of inst, not ref of inst. So if I misspelled inst, that would fail during Python time and not during the CloudFormation upload, which is a lot faster. So now that I have the JSON, regardless of how I created the JSON, I can use it to build a fresh stack. The only thing that's really important in this slide is the second line, which is the create stack line. Unfortunately, apparently people like to know if the stack has actually succeeded to build or failed. I know. And there's no good way to figure that out other than a long polling loop. So you write a polling loop to check the state. Updating a stack is actually very simple. You just create a new JSON. It does not have to do anything with the old JSON. Ideally, it should be a small variant, but this is not checked. And basically, when you upload that JSON, you can say, push it, but do not act on it. Tell me what you're going to do. That is called creating a change set. Now, I said that you can use the UI for read-only access. This is like one of the classical ways to use the read-only access. You can see what changes it's going to do. Make sure these are the right changes. Otherwise, we automate, right? Delete that change set and create a new one. And then, if that looks like something that is reasonable to do, you can apply the change set. You often want to have like what they call VPC Network, a virtual private cloud, inside the CloudFormation that will make sure that all the resources in the CloudFormation can talk to each other and are connecting to the outside world in well-understood ways. You can separate different stacks with different VPCs, so you literally can have the same IP attached to the same logical machine in different stacks. That makes it much easier to duplicate between staging, development, and ideally production. That will make sure that you build the entire network. So you build the VPC, you build subnets inside the VPCs, you build security groups inside the subnets inside the VPC. On the other hand, that makes sure that you actually think through who needs to talk to who and about what. So quick summary. You never want to log in as root after the initial creation or for like some weird emergency. You want to use CloudFormation for everything unless you use some other solution that is about as powerful. For example, a lot of people tend to use Terraform. Also good, but you want to use some solution that makes sure that you kind of build whole stacks at a time. And you want to make sure that you automate everything. And let's see how many questions we have. Awesome. Guys. Okay. If I don't have any questions, I'll ask myself questions. That's fine. I'm very good at asking myself. Oh, I don't see I have any. Oh, I do have some. Do I enable VPC pairing between the environment accounts to share persistent resources? So far, I have not needed to do that.
Hello?
Oh.
Yes. To your right. To your right.
Oh, hey.
Hi. Yes, I have a question.
Yes.
So,
Submit it through the form. And I will be happy to answer. So I guess I'll start by answering the easier question, which is I guess I skipped over that when I showed stuff. What is Salt? So Salt is a configuration management system. Usually you don't use it to build images. You usually build it for like post-boot configuration. But ideally you want to push as much logic as you can to the pre-build, because that will make sure you only do it once and you know when you've done it correctly. So if you're already using something like Salt, I guess other alternatives in that space are Ansible, Chef, Puppet, probably something I'm forgetting. So whatever system you use, I like to use Salt personally. Then you want to use it for the AMI build because you can move things back and forth. By the way, if anyone is interested more in Salt, Salt Stack, who makes Salt, have a booth right here. Okay, let's see what other interesting questions I have. How much more time do I have? 3 more minutes. Oh, excellent. Let's see if I have. I guess someone points out that post-admin accounts can't set up CloudFront key for request signing. That is interesting. I've never had to use CloudFront, so I did not notice that. But yes. I will definitely tweet out my slides. I will put them in a Git repo, and you can browse them to your heart's content after the talk. And I will publish a PDF that will be available through the website thingy. Okay, let's see if I have any more questions. Not right now. Okay, so I promise that I do know how to ask myself questions. So Moshe, what do you think about S3? Good question, Moshe. So S3 is a pretty nice system to store your data. It's stored in buckets. A bucket is a collection of objects, and it has a global unique name between accounts. Objects map names to content and metadata, and you can easily upload files. It is a very, very nice system to store small or large bits of data, like your images, your logs, and stuff like that. How much more time do I have? 2 more minutes, wow. Moshe, what do you think about snapshots? Good question, Moshe. It's very useful to take snapshots of volumes for all kinds of reasons, starting from being able to debug stuff in another environment to reproducing some system. You take a snapshot of a volume. You never want to make your AMI manually out of snapshots. You can do that. Please use the AMI creation APIs. Please, there are no good reason to manually do it from snapshots, which some people try to do. But for data volumes, snapshots are a godsend. You can use them for basically a halfway automated backup solution that you almost don't need to think about. They're pretty easy to take in Boto 3, pretty nice to automate. And when you want to recover, you can just create a volume of the snapshot. One thing I sometimes do is use it for like an ad hoc key management system. So I will literally put my private key in an encrypted snapshot and properly protect it with permissions. And you can even like say which key you want to encrypt it from. It is not as good as say something really high class and professional like Keys of Vault, but it is way, way easier to operationalize. I think I'm out of time, so thank you all again.